Right, you would just label, it's just labeled as the scoring went up or went down. But yeah, you'd follow the same procedure. Yep, exactly. You bet. Other questions? Yeah, Josh.
What if I did it completely differently?
So it's possible to think about it differently. I think you would find out in the end it's really the same way.
Okay.
Just looks different. I'll come by and look at it here in a second.
All right. Well, like I didn't do the work. Can I tell you what I did?
I'd rather just you and I talk about it instead of us talk about it out with everybody. I find sometimes what happens is people have like this unique way of thinking about it. It's either good or bad. And when they just throw it out there and other people hear it, they're like, I totally heard this one way that this one guy said, and now I'm confused. I don't want to do that. So I'll be happy to talk to you about it, though. Any other questions about 1, 3, 4? Yes. 1, 3? Sure. So number 3, listen, I just don't think you can get away from the idea that you need to start off with a picture. I think that's really important. So Los Angeles is where these two boats started. The cruise ship started here, and it went south. I think where people make mistakes is they make all kinds of crazy labels. I always label my picture with distances. So I'm calling that distance of cruise ship. And then the other one was a speedboat. It also started in Los Angeles, and of course it's going a lot faster, so it's going to catch up to that cruise ship. I'm going to call that DS for distance that the speedboat went. Most people, if they will just like buy in and say, okay, yes, Mr. Anderson, I'll draw a picture. They don't want to because they feel like it's unnecessary. If you're missing these, it's necessary, right? That makes sense?
Yeah.
I mean, it's possible to do these without. But if you're not getting these right and you're not drawing a picture, that's going to be my first suggestion. You ought to start drawing a picture. So the problem is, like I said, people will like label the distances with rates and all this stuff or times. You should label it with distances. Even still, once people get to this place, sometimes they really struggle because the next step can be challenging. But you can do it. What you need to do is take all the info in your picture and ask yourself, how can I relate these things? So for instance, like you could ask that question in a lot of ways. Somebody could say, hey, how are you related to Colton? And if I were to say, oh, he's my brother, is that true?
Incorrect.
Totally incorrect. I could say, he's my dad. Totally incorrect. He's my fourth cousin. Totally incorrect. I'm trying to relate us, aren't I? Do you get it? And so far, all the relationships I've thrown out there are just plain wrong. But if I said, he is my Algebra 1 student, there's the relationship, right? Or if he were in my life group, I could say, he's in my life group. If that were true, then I could also say that, couldn't I? So here's the point. What you need to do is take your picture and write a true, actual relationship. How do those distances relate?
They're equal.
They are the same. How do we know that? Picture helps, but how do we know to draw the picture the way that we drew it? What do you think?
Because it says that they caught up. Right?
Yeah, speedboat caught up, and where did they start?
They both started at the same spot.
Same spot. They started in the same spot, and because one boat caught the other, they finished in the same spot. Their distances, again, the picture also shows it, their distances had better be equal. Distance of cruise ship equals distance of speedboat. So you got to go there. So at some point, you got to go there. And then, of course, distance equals rate times time. And so the rate of the cruise ship is our unknown, so I'll put RC. For how many hours did the cruise ship actually go on this one?
4.
Yep, started at noon, stopped at 4. What is the rate of our speedboat? 40. And for how many hours did the speedboat actually go?
2.
Yep, 2 p.m. to 4 p.m. A 2. You can see we're at the end now, aren't we? To find the rate of the cruise ship, all I have to do is divide by 4 on both sides. 40 times 2 is 80. 80 over 4 is 20. So rate of cruise ship would be 20 miles per hour. I don't know. What do you think, Colton? That work? Okay. Thanks for asking. Anybody else? Any other questions? It's your last opportunity. Tomorrow we do this for real. Last chance to ask a question. Joe?
Might as well go over number 4.
Sure, number 4. So I like to handle stuff with parentheses first. So what I'd like to do here with number 4 is I'm going to proceed, and if I do something that's confusing or doesn't make sense, you stop me and let me know. So maybe my first step would be this. 10 squared, oh, that's, sorry, a little bit blurry. 10 squared, x to the 14, y to the 8 times, I'll do the other one here in a second. Does that make sense so far? I multiplied those exponents, right? And then over here on the right side, it's going to be x to the 0, y to the 11 over 5. I'm kind of skipping a little bit of steppage here. What do you think?
X equals 1 because anything.
X doesn't equal 1. X to the 0 equals 1.
Yeah, X, that's what I meant.
Yeah, we can go there if we need to, but yeah, you're totally right. Are you okay with the y to the 11th? Are you okay with the fact that the 5 stayed exactly where it was in the denominator?
Yes.
Okay. So then to finish this one, what I would look at is I would see the x to the 14 and the x to the 0. If I'm multiplying bases, what do I do with my exponents? 14 plus 0 is 14. So I'd get 10 squared is 100. So it'd be x to the 14. And then, of course, I've got y to the 8 times y to the 11. Once again, if you're multiplying bases, you add your exponents. Yep. So y to the 19 over 5. The final step is to recognize that 100 over 5 is really just 100 fifths, or 100 divided by 5. That's 20. What do you think, Joe? Did I do a good job? Okay. All right. We good? Okay, cool. So flip over. Flip back. We're going to do a little bit of factoring, and we're going to do one from the past. So please check out number, we have not done 3, am I right? So please look at number 3. Let's see if we can connect this to what we did the other day. Ready, set, proceed. Think of this as a little warm-up, a solution for number 3. Hey guys, let me give you a couple of procedural thoughts here to help give you some direction. First of all, 2x squared minus 11x plus 12. What is that? It is a trinomial, but this is a special one. Special enough we gave it its own name. Quadratic. I mean, that is kind of an awkward name. I don't know anybody who would name their kid quadratic. But that's the name of this thing, right? So if you have a quadratic and you're going to factor it, you need a 2x2 box. So here is my 2x2 box. What do you guys think should go in the upper left corner? Yeah, it's always going to be your lead term. So 2x squared, the whole thing. What always goes in the lower right-hand box? The c, which in this case is? 12. Okay. We've got to figure out what goes into the other two boxes. In order to do that, I need to figure out what a times c is. A times c is? 24. Had a couple of really interesting conversations as I walked around. There were folks that were honest and like, I am really struggling with how to figure out which numbers multiplied to be 24. There's some really obvious ones, right? So 1 times 24, that's a pretty obvious one. Or negative 1 times negative 24. Why do neither of those work for us on this one?
Because they don't add up to negative 11.
When you add them, you don't get the b value. Yet you don't get negative 11. So you got to explore a little further. I'm hoping that you would look at 24 and say, hey, 24 is even. So what number always goes into even numbers? 2. So you could say 2 times 12. And if you're struggling with the arithmetic, for goodness sake, just use your calculator. But 2 times 12 doesn't work, does it? Because it doesn't even add to be a negative number. What about this? Would this work? Gets us to a negative, and we're getting closer, aren't we? But we're not there yet. Maybe this would be the point where you're like, you know what, I really don't know any other numbers that multiply to be 24. This is where you break the calculator out, right? And what I would suggest you do, especially if you're struggling, is to be organized in your thinking. Notice how I went from 1s to 2s. What would be the next logical thing to think about? 3s. Does 3 multiply to be something times something to get 24? 8. Does 3 and 8 work?
Almost.
Oh, it's almost. What do I need?
Negative.
Yep, negative 3 times negative 8 is positive 24, and you can see now that those add up to be negative 11. Does that work? Okay, so what you do is you take those and you use them here. So negative 3x, negative 8x go here and here. It doesn't matter which one you put it in. It'll end up being the same in the end. Here we go. Now we factor from right to left. What's in common? What's in common on that row?
X.
They both have an x. I agree. What is in common on this row?
Negative 3.
I think they both have a 4, but is it going to be a negative 4 or a positive 4?
Negative. That's a finishing box.
Yep, finishing box is negative, so you got to go with negative 4. That's right. Factoring up, what's in common right here? Negative 3 is in common. What's in common there? Okay, so that means our factoring will end up being 2x minus 3 times x minus 4. What do you think? Follow-up questions on anything that I've showed you?
No, we didn't.
These should both be... Oh, so make sure you're paying attention. 8 times 3 is 24, but 8 plus 3 is positive 11. So listen, I noticed. And I want to move forward a little bit into our next, one of our last factoring topics, and it's right here. And to start us off, I thought we could do a little bit of multiplying. So if you guys would, look at those first two ideas there, and I want you to multiply, and I want you to think about a pattern, okay? So multiply the first two together, do the same thing with the second one. I want you to think about the pattern that starts to emerge when you do that. Ready, set, go. See if we can agree, and let's discuss, okay? So the first one should be this. Second one should be that. So, questions?
You get a single box.
You have to do a box?
Yeah.
No, box, so I like the box method because it's incredibly consistent with all the stuff that we do, but that's far from the only way to do it. There's lots of ways to do it. No, there's lots of ways to do these. Lots of ways to do these. This is one of them. So what pattern did you see as you were multiplying these out? Something should kind of stick out to you as like, whoa, that's hadn't happened before, or I don't know why that happened, or what do you see? What do you see, Jaden? Never mind. Okay, what do you see, Noel?
Well, when you're multiplying with one negative and one positive with the same numbers,
Yep.
the middle numbers get canceled out, so the things with 1x or
So go back. So she described this really well, didn't she? She said when you're multiplying two things together that are the same, except one's minus, the other one's plus, she said the middle numbers cancel out. Am I saying that right?
That's how I said it.
Let's go back to what she said. She said the middle numbers cancel out. Let's say it like this. The middle numbers always added up to be 0. Really important that we understand canceling out is sort of a vague thing. It's like, what does that really mean? In certain contexts, it can mean this, and others it means that. But say it correctly. Those two middle numbers, they add up to be 0. So that's going to be the pattern. I'll say the middle numbers add to 0. There we go. So the middle numbers add to 0. I'm not going to really, this will probably slip out because I'm just used to saying this. I'm going to try to not focus on this too much. You might have heard this phrase before for these. Has anybody ever heard of this? Difference of squares. If you've never heard of it, that's no big deal. I'll probably refer to these as that from time to time because that's really what they are. I'm not going to make a big deal about that. I just want to make sure you know how to factor. Okay? So let's do one of these examples here. There's 3 of them, and I thought we could do one of them together. Let's see how much time we have. I might have you do another one. So here we go. Let's take a look at number 1. I'm going to use the box graphic organizer again. I'm going to be very consistent with this. So let's take a look at this first one. This is technically a quadratic. It might seem like it's not, but it is. If this is a quadratic, what's your A value? A, listen, A is, listen please, this could be tricky and I don't want you to miss it. A is definitely 16. What's B?
No, it's -1.
You want to say 25 because it's the very next number. But remember, a quadratic is based on ax squared plus bx plus c. So c is actually negative 25. Sorry to get in your way. C is negative 25. B doesn't seem to be there. B is 0. B is 0. Okay? So check this out. In my box, what always goes in the upper left-hand corner? Not just the A value, the whole first term, right? So it'd be 16x squared. What always goes in the lower right? Negative 25. How do we get those other two boxes? Yeah, we multiply AC. So what is 16 times 25? 400. So the AC would be negative 400. That's such a big number. Here's the thing. Here's where you can really help yourself. I want you to think logically about this. What do the two numbers have to add up to be? 0. And so let's think about like what kind of numbers add up to be 0? Okay, yes, I like where you're going with that, but like think a little more generally. Like what kind of numbers?
200 and positive. Oh wait, that'd be like -20 and positive.
If the numbers are opposites, right? So think this through. If I were to do this, yeah, Callie is a little bit too large, but that's okay. If I were to do this, do you see how this is, although somewhat logical, because that does multiply to be negative 400, from the perspective of adding up to be 0, it makes no sense. Wouldn't this even almost make more sense to write something like 10 times negative 10? Now that doesn't multiply to be negative 400, so that's not going to work, but do you see how those would add up to be 0?
Yep.
So Callie, did you eventually get to the right place?
It's 20, negative 20.
Yeah. 20 and negative 20, well, those multiply to be negative 400 for sure. And they add up to be the 0, which we know the B is 0, right? So I would go here and here. And now I'm in the same place that I've been this whole time with factoring with the boxes. So let's see how this turns out. So I factor from right to left. What number is in common? What goes into both 16 and 20? 4. And of course there is an x. Should this be a negative 4x or is it okay that it's positive? Finishing box tells you, doesn't it? Okay, now over here on the bottom row, what's in common between 20 and negative 25? A 5, but should the 5 be positive or negative? Finishing box is positive, so yeah, plus 5. Factoring bottom to top. What's in common on the first one there? What goes into 16 and 20? 4 and x, so you got 4x. Look at this. What's in common between those two? Negative 5. And then when you look at the factoring, you get 4x plus 5 times 4x minus 5. Do you see how that's the same pattern of multiplication we looked at a few minutes ago? It's that difference of squares pattern goes back to this every time. Okay. So guys, I think that's all I've got for now as far as new stuff goes. We're going to come back and we'll review this again tomorrow. And we'll keep rolling. Like I said, tomorrow again is about factoring. For now, please...